Welcome to episode 2 of Verifiably Random. I am Marc I'm the CMO of Algorand Foundation.
Hi, and I'm Min. I lead Ecosystem for Algorand Foundation.
And hello, it's John Woods, the CTO at the Algorand Foundation.
Well, great to have you guys here, and great to do this episode together. So today, we're going to do it slightly differently. Today we're going to focus on Python. And rather than focusing specifically on Algorand and on the Algorand developers, we want to basically broaden it and talk to all of the Python developers out there and talk about why Python developers should care about blockchain development. So it's not going to be so much about Algorand itself, but more generally about the blockchain industry and why it's useful for Python development.
You know, I'm glad, Marc, that we're doing this because one of the great advantages of going to the bother of bringing a mainstream language like Python to our platform or to any operating system is that you do attract new talent, you attract new developers, and they bring new ideas and new fun things to interact with. So I think it's really important, and I'm really delighted that we're kind of broadcasting out into outer space a little bit, and hopefully catching the eye of people who might be interested in this new paradigm in software engineering.
And it's kind of interesting when you look at the blockchain industry in general. I think there's about 30,000 specialized blockchain developers out there. There's a community of 10 million Python developers, and so there's an opportunity here to bring some of these Python developers into kind of the blockchain world and kind of show them what the advantages are of decentralized computing and how it can actually help their existing projects. And so that's what we're trying to do here. See if we can actually attract them and show them and inspire them about all the use cases that are useful in this new world.
Absolutely. I think as well, it's like not only does Python make it easier, I think, chiefly one of the most important things is that it reduces the learning curve. Because whenever you're building on a new platform, I remember when I was first getting into mobile development, I started on Symbian OS, which was like a Nokia's smartphone platform.
Oh gosh, pre-Android.
Hello World on Symbian C++ was like 3 class files, 100 lines of code. It was like just a nightmare to learn. But the learning curve was so steep. But then it was something wonderful about this idea that my first app, I had built this app that like could tag the cell towers with like little IDs, and so I kind of was able to tell how long the train would take to go to work based on like as I passed the cell towers or whatever. And so, but like there was something amazing about that new paradigm. This idea that like my app was running in my hand as I moved, because previously apps ran on a computer on a desktop in my house, and you couldn't interact with the real world. And so, I just remember that like the learning curve was worth it, but ultimately so many people didn't bother with Symbian until something like Android came along or something like iOS came along and made it easy. And so just the parallel there is by bringing Python, we've crushed that learning curve. I mean, yeah, sure, some people, took Teal and built new and exciting things. But now with Python, it makes platforms like Algorand incredibly accessible.
Yeah, and so let's talk a little bit more about the pre-Python world on blockchain. We're going to get into use cases as to why you should care a little bit later, but let's maybe start talking about that. Like if you wanted to develop for blockchain before kind of Python arrived, what would it look like? The barriers were pretty significant, aren't they?
Yeah, and so maybe we should take a step back and talk a little bit about what it means to develop apps for a blockchain as a platform and as an operating system versus maybe more traditional platforms like your laptop or your desktop computer. So, when you're learning software engineering in college or school, the first thing they will teach you about is, of course, the basics of how you express business logic in a language, but also to recognize that the things you type, the code you type, doesn't run on the computer directly. Instead, that code where you say, if this, then that, that logic, that code that you write, that gets compiled targeting a particular architecture. And so, when you write code, you must, before you can run the application on any computer, whether it's a smartphone, a desktop, or indeed a blockchain, you have to compile the code down to what's known as machine language. And this machine language is quite literally ones and zeros that the CPU or the brain of the computer can interpret and process and do instructions upon. And so, when you write that first Hello World app on Windows, and the code is essentially print Hello World, before that spits out the words Hello World to the screen, you must compile, and then the compiled binary, the ones and zeros or the machine language code, is run by the computer. And so it's actually no different on a blockchain. It's just a bit more constrained. And so maybe just like when you move from a desktop computer down to a cell phone, and you have not as much memory on a cell phone and not as much compute power on a cell phone, you got to think differently about your app. You can't just brute force your way through things. Writing apps for that smaller screen and those smaller resources makes you write apps a little bit differently. Again, we can take one step further on blockchain, and we can say that when you write apps on blockchain or write apps targeting blockchain, you also have to work within the constraints of the blockchain. Now, blockchains broadly, not speaking about anyone in particular, are very powerful, and they enable classes of application that are just not possible on other platforms. And we can discuss a little bit later. We can get into maybe some of those use cases and why they're important. But just if we take for this moment and we say, if we accept that, okay, if I want to take advantage of these blockchain-specific use cases that are only possible if I target blockchain as my platform for my app, one then has to realize that the code I write, the app for the blockchain, which we all call, by the way, a smart contract. A smart contract is an app on blockchain, essentially. That code will have to get compiled down to a low-level machine language that the blockchain understands. And so, continuing with this comparison to phones and to desktops, the Intel chip in your laptop, right? The Core i7, the Core i9, the AMD Ryzen, the ARM chip in your Apple Silicon laptop, the M1, M2 Pro, the M2 Max, these things. Algorand has its own CPU like this. It's called the AVM. And when you write apps on Algorand, you're targeting the AVM. So your code gets compiled down into what's known as bytecode that gets run by the Algorand virtual machine, which is a virtual CPU essentially. And so that's the start of a blockchain journey. And then to very quickly answer your question, prior to AlgoKit, which is our product that helps you build, test, and deploy apps on Algorand, and prior to the release of Python for Algorand, so you could write apps just in regular Python, individuals had to go and write very low-level code, very close down to that machine code level, in order to get Algorand to do things. And so that wasn't very much fun, and that's the learning curve I'm talking about.
And that was the case for all blockchains, right? Like if you want to develop on Ethereum, you had to learn Solidity. Like other blockchains have similar kind of more low-level type of languages. Is that right?
Yes. So maybe we could explore two that I know quite well because I worked on them. Ethereum has the Ethereum virtual machine, which of course is very, very similar to the Algorand virtual machine. It's just not as fast and not as precise. And Cardano has its own kind of like a virtual machine, kind of like a virtual CPU. It's called the Plutus interpreter, and it runs Lambda calculus or Plutus code. And so, yes, all blockchains have this low-level CPU, and indeed, they have languages that you use to tell it what to do, to run apps, just like we write code on desktop computers. What's interesting, though, maybe, is that Ethereum's been around a long time. It's been around, very popular since 2014, 2015. Okay, and so it's had a long time for its developer tools to mature, just like the iPhone, just like the Android Studio. It's had nearly a decade for those developer tools to get great. And so Ethereum does have its Teal equivalent. Okay, there's an Ethereum instruction set, but no one ever really used it. People kind of got to start off in Ethereum using Solidity, which is like JavaScript. And I think that's probably the great advancement in understanding what AlgoKit 2.0 brings to the Algorand platform. AlgoKit 2.0 brings that moment of ease of use. It brings that kind of Solidity level ease. You just have to use regular Python now to build your apps rather than having to write your apps in lower level primitives.
And so what does it take?
John.
Yeah.
Oh, go ahead.
So what does it take for a Python developer to get started? So they download AlgoKit and so can you talk a little bit more about that?
Yeah, sure. It's quite literally 2 lines. You go on your computer and you type, if you're on a Mac, you type brew install AlgoKit. If you're on a Linux box, you type pipx install AlgoKit, you hit enter. It installs just like any other package, just like installing Mozilla, just installing Chrome. It's as easy as that. And then you just go back to your command line, type AlgoKit init, and then that's it. You name your project. It gives you a template. You click play, and then you've got an app running on testnet. It really is that easy. It's really great. It's quite literally as easy as your first app with the iPhone. It's as easy as your first app with an Android phone. AlgoKit init. That's all you got to do. Yeah, Min, what were you going to say?
Yeah, I was just gonna say, you talk to us a little bit about how we got to, why Python, because I think it sounds like, of course, reaching 10,000 or thousands of Python developers out there. But also, I feel like there's some unique characteristics about Python that could really be interesting for how you think about developing.
Absolutely. So when we chose Python, we did it for a number of reasons. I mean, with all kind of major engineering decisions, it tends to be a mix or a cocktail of different reasonings. The rationale behind Python was essentially kind of threefold. The first, AlgoKit itself is written in Python.
Oh, I didn't know that. I did not know that. Yeah, yeah, yeah. That's cool.
And in software engineering generally, it's and by the way, we chose Python for AlgoKit because it's fast,
Yeah.
powerful, and simple to write, simple
Yeah.
to maintain. Things that you need, by the way, in your smart contracts. Um, and so it's when you're building software, it's easier if you don't mix languages so much, and so we chose to stay with Python for that reason. A second reason is because it's quite literally one of the most popular languages in the world, alongside TypeScript, which we're going to bring later this year. And then I think finally, if I had to pick one further reason, it was a bit of a speculative bet, but we noticed how excited people were getting over ChatGPT 3.5 at the time, and we felt maybe, you know what, wouldn't it be great if we had a language that's encompassing everything from the students in high school, because they teach Python there because of its simplicity, all the way to the high-end kind of machine learning experts, data ML engineers, of which now many people are going to university with an interest in this. Many people are naturally learning Python because of this industry that's booming. And so, yeah, I think it was the right choice in hindsight. But essentially, the most important characteristic was that it was a world-class language that was simple, easy to use, and very popular.
But the one thing I'm super excited about Python is actually the ability to bring in all these experienced developers, not just Web3, right? Like Web2 experienced developers. And if there's one thing about blockchain, dApps, smart contracts, it's really the UI and the UX that we really need. We really need to like work on, and I feel like these experienced Web2 developers can really bring that into our ecosystem, not just our Algorand ecosystem, but more broadly the blockchain ecosystem. So I think there's also just like this tapping into the experience of these Python developers that I think is pretty exciting too.
Totally.
I
That's
didn't
a
mean to cut
great
you
point.
off.
No, I think that's a great point. So another point, John, I heard about like how real is this Python? Like how is it real Python? Is it like
Right.
because like there's a lot of these kind of Python-like kind of languages that exist that kind of
Yeah.
look and feel like Python, but they're not really Python. So like talk a little bit about that. How real is this?
I think it's really important. And so, short answer, TLDR is very real. You can clip that one out if you want. but but the longer answer is, let's take a look for a moment and talk about what it means to run code on a blockchain. Because earlier on, I said the desktop is very open when it comes to running code. On a phone, you have more constraints: memory, screen size, blah, 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 blah. On a blockchain, I said there's other constraints that one must consider. So let's dive into them. For example, on a blockchain that's super fast, like Algorand, the blocks are every 2.5 seconds or so. So your code can only run for 2.5 seconds at a theoretical maximum, right? Of course, it has to be faster than that for other reasons, because you got to make the block, validate the block, send the block, blah, 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 do consensus, run the VRF. But, block time is a hard limit on how long your code can run. Also, when you build apps on a blockchain, which we'll talk about later on, to enable certain use cases, that code must run on many computers simultaneously around the world. So it can't run for like 25 minutes. It can't use 15 gigabytes of RAM. Your code has to be quite succinct. And so you'll see on every blockchain platform that allows you to write smart contracts or apps, you will see whether it's Ethereum, Cardano, Algorand, or otherwise, you will see that there are limits around how much memory and how much CPU or brain power your application can use. And so one must write an application thinking about this stuff. And so if you look at smart contracts, they tend to be, a couple hundred lines of code. They're not hundreds of thousands of lines of code. So that's one thing that one has to consider before you even begin to think about how you allow someone to write an app for a blockchain. So thinking about those constraints now. Secondly, it's very important to recognize that there are certain things that you just cannot do in a smart contract. When you're running code on your desktop computer, generally speaking, those desktop computers don't have a GPS chip. So you can't ask your desktop computer, where are you? And check the GPS satellite for me and tell me where you are. It's not a thing you can do on a desktop generally. You can do that on a cell phone. On a blockchain, similarly, there's certain restrictions around what you can and cannot do. So for example, all blockchains globally essentially do not let you make web calls. You can't call a web API arbitrarily on the internet from a blockchain. It's just not possible to do in a decentralized way, so you're not allowed to do it. You can't execute code that maybe, for example, accesses low-level functions on the computer, like creating large files and other side effects. These are things you just cannot do. So now knowing these two things, and these apply to all blockchains, right? These constraints around time and compute. These constraints around things like you can't make a web call from a smart contract. This is globally across the industry the case. So this precipitates the reasoning behind certain linguistic choices or language choices on different blockchains. So if you look at Solidity, why didn't they just take JavaScript? I mean, everyone tells me Solidity is just JavaScript, right? Answer, because they knew these constraints and they wanted to write a language that was limited around them. So a language that was a subset of Solidity, of JavaScript rather, that is respectful of these boundaries, and it tries to enable success for the user. Now, to answer your question, you said, well, doesn't Ethereum have Viper, and isn't that Python? And so, no, it is not. Again, the guys behind Viper, they've kind of said to themselves, well, we have these bounds, these constraints. We only want people to be able to do certain things. And so we should definitely write a language that has the syntactic sweetness of Python. It's easy to write, and you can kind of make sense of it fairly easily. But it is constrained. We did not take that choice. We decided not to constrain the language, not to artificially create a flavor of Python. And this is, to answer your question, this is the differential. On Algorand, of course, those restrictions still apply. But we decided to use regular, pure, normal, textbook, normal Python. Semantics and syntax. Now, syntax is the way that the code looks, the actual the words you use to write the code, the expressions that you use. So any code you write is exactly normal in terms of the syntax, but also in terms of the things that you can do. So because we knew that there's certain things in Python that Python will let you do that you just wouldn't make sense in a smart contract, we boxed off a certain area, a subset of Python, but we still allowed the use of regular Python tooling. And I think that is the critical piece. Although, yeah, sure, you can't use Python to make a web call from an Algorand smart contract. You can use, because we've taken this hard choice around the semantic and syntactic correctness of our Python implementation, rather than making a flavor of it, you can use regular Python tooling and Python developer frameworks where it makes sense in a smart contract.
So the key thing about this is that if you're a Python developer, you can use all the existing tools and development environments that you're used to, and then just take that knowledge with you and start developing smart contracts.
Precisely, because we didn't make a variant of Python, we're just using regular Python, where if you try to do a thing that doesn't make sense, like make a web call or something like that, the compiler will just say, hey, you're in a smart contract, dude. You can't make that call. That doesn't make sense.
John, but what about the other, this point around us not constraining the adoption for, how we implemented Python? There, what this is a good time to maybe bring up some questions that we've seen in the community around. What about some of the fundamental constraints of Python? So, for example, some of the complaints that we've seen, or not complaints, but some of the feedback around Python is that it's slow. It could potentially be slow dealing with a ton of data. How does that impact, our implementation and developers building on Algorand? With
Yeah, a really interesting question, actually. I was just speaking about this with the engineering team the other day. People have that assumption because they look on the desktop and they say, well, I'm going to compare C++, which I write the code, it gets compiled down to machine code and runs in a very, very lean C++ runtime, versus Python, which traditionally on the desktop gets compiled down to an interpreted language and then runs in this middleware, this kind of Python VM type thing. And so it doesn't run as close to the hardware. Python traditionally doesn't run as close to the hardware as C++ or Rust or Swift or whatever.
Mhm.
And so it has this name within the financial industry of maybe being great for prototyping, but a little bit slow in execution compared to some of those systems languages like C. Well, we're not going to an interpreted middleware. We don't have that Python virtual machine. And this is the amazing thing about what the team have done with their LLVM-like compiler pipeline, which is a state-of-the-art way to take smart contract code and get it to run down at bytecode. The Python you write, the syntactically regular, semantically normal textbook Python that you write for your smart contract, gets compiled down all the way to native Algorand machine code. And it runs directly on the bare metal of Algorand, if you like. It doesn't run in this interpreter. And that's the reason why your contracts written in Python will be as fast, if not faster, than your Teal contracts, because we are optimizing them and because they call the same low-level instructions that Teal does. So great question.
That's super cool. That is super, super cool. Yeah.
So another question, and actually that leads us to our second segment, that Python developers we hear a lot is like, okay, I understand I can do this in Python now, but like, why should I care? Why should I care? So why bother developing for blockchains? And so kind of that leads us to kind of our second segment in the podcast, is to talk about what are some of the use cases for blockchains that Python developers should look at as they consider developing for a blockchain. And there's a couple that we can talk about, but maybe let's start with this disintermediation. I think that feels like it's a big one that we should talk about.
Yeah, man. Do you want to start us off, man? I think, I think actually, by the way, I agree, Marc. Disintermediation is, I think, it's the raison d'être of blockchain. Like, yeah, man. Maybe what do you?
I mean, this is one that I think we can all relate to, right? I think disintermediation is an area that I would say most blockchain projects start with. So if you think about DeFi, disintermediating, right, like the financial institutions and structures in place to do some of these lending, borrowing, staking, etc. NFT, I think, is even a disintermediator, right? Like you can directly interact and reward the artists and be fans of specific creators. And I think, we also have some really other interesting projects, but I think the idea of disintermediating is allowing two parties to directly interact and peer-to-peer sort of transactions or interactions without having a middleman. And I think this is something that's so relevant. In fact, I know our boot camps, I'm going to sort of put a plug in there for our boot camps. The project for our boot camp is to build a digital marketplace. So if you think about a marketplace, in the traditional sense, there's always a middleman. There's always a middle person, right? That's the person that operates this middle marketplace. But in blockchain, you can now create a peer-to-peer marketplace of any kind without needing the central entity. So I think, to me, disintermediation is one that is almost like the beginning, the birth of apps on blockchain.
Yeah, we have a lot of projects that are really playing into this notion of disintermediation, right, on Algorand?
Totally. And so like here's the thing, right? I think that Web 2, right, the original internet, it gave like a soapbox for the individual to stand up on. So like, you could run a cake shop from Bolivia, you could like sell like, the stuff that's on Etsy now could be sold peer-to-peer on the original internet, right? Because someone could discover you, and so it gave that power to the individual. And I think that I think you're right, Marc, with this disintermediation. I think that is the most powerful um, fundamental feature of blockchain. It's killing the middleman. And maybe I'll let you maybe go through some of the example projects. I think Book.io is very great. I think Day by Day is an interesting one. It's about to launch. Book.io, by the way, it's your Amazon Kindle, okay? Except for rather than buying a license for the book, you actually get a self-sovereign copy of the book, right? Day by Day is trying to disintermediate insurance, make the contracts for the insurance NFTs, make the liquidity for the insurance provider payouts, liquidity pools, etc. So, but it's so important that we remove some of these middlemen. I mean, I'll give you my two least favorite middlemen in my life at the moment. Number one, when I get a cab in Ireland and probably around Europe, to get a cab, the app is called Free Now. I hate Free Now. Now they're a broker between me needing a cab and the man driving the cab who also wants a customer. And sure, it's useful, but it'd be so much better if I could just meet that person on my own. And they charge me like $3.90, and on the receipt it says technology fee. I don't think so. And the second one is Ticketmaster. When I go to see Guns N' Roses, okay, when I go to see Radiohead, these are like the bands I like. Who else? I went to see Pulp recently, very cool as well. I'm a bit old now, but whatever. Pulp is cool. I don't want to pay you €7 for like selling me a ticket, okay? And so I can't wait for those middlemen to be slaughtered.
It's funny because like the original promise of the web of internet was disintermediation, right? The fact that as a merchant you could basically connect directly to consumers and do all the transactions that you want, and then somehow something went wrong along the way, and all of these walled gardens were created, and all of this it was re-intermediated, if you want, and so we have another chance, I think, of getting at this disintermediation future or ideal with blockchains, which I think is really, really interesting.
Absolutely agree with you. It's a second bite at the apple.
That's actually a really interesting point. Like Web 2 was trying to disintermediate, but it didn't do it because now we're stuck with another like intermediary in the middle. Yeah, that's so fascinating.
Yeah. So what else? What else I think is important? Data provenance is another one, right? That's another one that we should be talking about.
Yeah, I mean, maybe I'll touch on this one. I think it's root of trust. This idea of a chain of trust. I can trust the provenance. I can trust. My favorite one, because I love eating food, is the farm to fork. Where does my cattle or the animal that's slaughtered originally come from? What farm is it from? How is it treated during its rearing? How is it processed during the food supply chain? And this can apply to everything from food to pharmaceuticals and drug manufacturing,
To coffee.
all the way to luxury goods, coffee, Lavazza. Shout out to Lavazza. But yeah,
Yeah.
I think this idea of a decentralized root of trust, this ability to walk through the chain in a way you can verify every single step in the process. And indeed, I think, by the way, we're going to end up in a situation where designer handbags, very expensive clothes, this kind of like luxury goods, whatever they are, watches, whatever. These products will eventually, I think, come with a digital attestation of their veracity, and I think that's a very cool thing.
I think it's
John,
even
I don't know
cool.
if you. Oh, go for it, Marc. Go ahead.
So I think it's even cool if you think about like AI, right? Like data provenance, like in the context of AI is also quite critical. I mean, there's a lot of conversation right now about like these big AI models that are basically getting their data from everywhere, and publishers obviously are unhappy with the fact that their data is being used in these gigantic AI models. So is this something that could actually be used here as well? Is like figure out a way to basically for publishers to be able to know that their data is being used in these big AI models and use kind of a blockchain to be able to track that. Is that a relevant use case, or am I just imagining something?
No, I certainly think that there is a mechanism there by which one could, assuming both parties are, of course, you can't stop screen scraping and things like this, but once both parties are willing to pay a royalty, which of course these big companies like OpenAI and Reddit and wherever else gets scraped are probably likely be willing to do. I think there's absolutely then a mechanism for to use blockchain to facilitate those royalties, if you want to call them that. Yeah.
Well, I mean, at a minimum, there's a place for blockchain to capture like the provenance of that data, right? So there's a lot of the content. For example, LabTrace is a company that is really bringing, right, like health data on chain. Like, so any sort of data, could be images, it could be data, but it's all about the timing and it's about the sequence of that data, which of course the blockchain can really capture. And I think so there are elements of, data, whether it's or content that the blockchain can really kind of bring in the value for. And I even actually, John, when you were talking about supply chain, I was just thinking about Whole Chain, which is this fantastic product. It's it's a software that basically they trace they call it custody of, I'm forgetting what it's called. Oh, chain of custody,
Hmm.
basically, right? And so it tracks events that the different food goes through in the supply system, in the supply chain system, and through that they can not just verify the that a food comes from a specific place, but it can also find fraud and find issues in the supply chain earlier than without using the blockchain. So I think there's some really amazing use cases for blockchain as a provenance as well.
And I'll just finish up on this one, but I think it's important. At the moment, people just kind of accept that we don't have the ability to verify these things. And I remember there's a time when ingredients weren't forced to be written on a packet of a product, but now they are. And now we expect it. We expect to know the nutritional values of the things we put in our body. And so I think we're going to get to a place where people are going to be like, well, how do we live without the ability to verify the authenticity of the things that we're doing?
I mean, right? How do you know it's organic? How do you know if it's not GMA? Like all
Yeah.
that stuff. Yeah. The validity of it is yeah, it's super important.
I think one more use case is probably. Sorry, Mark, did you want to build on that one? Or?
No, no, no. I think I was going to move us on to the next one. So what do we think is what other use cases do you think are kind of useful?
I'm hot on like DIDs, like decentralized ID, self-sovereign identity. I think that is this idea that you own whether it's identity or not. This idea that you're in control, you own the asset, you own the transfer rights, whether that's royalties, NFTs, ownership of assets, or indeed an identity, like the ability for me to have an identity that isn't rooted in a centralized authority like a government. Not that there's a problem with having a passport issued by your country of residence. Of course, that's okay. But to complement that, it may be useful to have an identity that you control the issuance, attestation, and indeed the use of. That is not controlled by the DVLA or the Drivers Association or your government.
I think the element of like what's interesting about this as well, I think, is a true element of ownership, right? The fact that you can really own things for the first time, like in a Web 2 world, you really don't own anything, right? If you have a Google account or you have an Amazon account or you have a Twitter account and you have a bunch of followers and you have a social network, you don't really own any of it, right? You don't own the account. You don't own your followers. If you basically want to take your followers from X somewhere else, you can't take them with you. So the notion that you can actually truly own something and then and you own your social network and you can take it with you, to me feels like a very powerful thing that only a blockchain can really deliver. So if you're a publisher, right, if you're an artist, if you're a creator and you've spent so much time and money to build your following and your fan base, you ought to be able to own it and take it with you. So that's a little bit of the promise of blockchain in that regard, isn't it?
Absolutely. I mean, like if Steam banned me from this platform, I lose access to thousands of dollars of games that I've bought. If YouTube banned me because I make a comment or something that they don't like, I lose access to hundreds of movies that I own on the YouTube platform. The same with my Gmail, my emails that I have. The same with my Amazon Kindle books. There's countless examples. And actually, we don't realize how beholden we are to all of these entities who've essentially, by the way, licensed the use of their products and indeed the content on their platforms. And yeah, I'm a person who enjoys self sufficiency, and maybe maybe I should go and build a bunker somewhere. But I feel it's useful to be in more control than less control.
My biggest issue is, like KYCing at 100 different platforms. I'm like, I already gave all this information at this one bank. I'm going to have to give all the same information at this other bank. And again, like how many times have we all gone through the same process? And every single time you go through it, you're like, oh my gosh, what if there's an exploit and somebody takes all my information? I think this idea of self sovereign identity is one that is incredibly powerful, but I also, I just also want to point out, I think it is one of the hardest ones to really do. And, I think because of all the forces against it. So, but it's so powerful.
So there's a couple of other use cases that I really like that are like not like these kind of high level like big topic items, but like also very practical things that if you're like a Python developer and you're working on an existing project and you not want to start from scratch, that could be interesting to add blockchain to your project as opposed to starting like completely new. And so one of the things I was thinking about is like this whole notion of transparent and auditable record keeping. The fact that you basically have an immutable kind of ledger that you can rely on, that you can possibly integrate into your apps. And if you think about like notarization or like just recording contracts and having like fixed timestamps that are immutable, feels like it's something that is really really interesting to kind of integrate into applications that can take advantage of that. You don't have to come up with this whole new kind of like Web3 thing. You can just integrate blockchain as a piece of functionality, as a piece of infrastructure into your existing apps. I think that's quite interesting as well.
That's so funny because, in fact, we're gonna do a space later today with a project that is doing notarization on chain.
Oh, really?
Yeah, yeah, but I'm gonna keep you at bay. I'm gonna let you wait to hear that space to hear what exactly they're doing.
That was pretty cool. There's this other project I think that's running on Algorand, which is I'm very excited about. This is a data history museum, and the idea
Mhm.
is that they basically timestamp these like real world events like earthquakes and stuff like that. And so it goes kind of beyond like auditable record keeping. It goes like it keeps track of like the history of things. And so it's the idea of like having a common and unique arrow of time that can be kind of mined by historians multiple centuries later, and it cannot be faked, and it's immutable because it's recorded with a timestamp on the blockchain. It's like the entropy in the analog world is now becoming digitized with a blockchain, which I think is super super cool and interesting to think about, and something historians may be interested in.
Yeah, I love that project as well. It's super cool. I also love the fact that it does solar flares and other things like that. And I think if you're a Python developer, regular normal Python developer who's building desktop, laptop, cell phone apps, um, and you're interested in trying something new, and this is not going to overhaul your entire architecture. You're not going to take your Python application as it currently exists and like throw your architecture in the bin and start again on a blockchain. That's not what I'm suggesting. Rather, I think if the use cases we spoke about make sense, have a look at where maybe it might be interesting with very little effort, now that it's the language you're already writing in, to maybe add a component to your existing product that leverages some of these things. So, for example, um, if you're paying someone some kind of middleman service to do document signature for you, maybe get rid of them and try notarizing your documents on the chain. If you're currently, requiring some kind of timestamp, and you're paying someone to record a timestamp in Amazon RDS or something like that, maybe record that to the chain for cents at a time, for less than a cent. And now you have a cryptographically attested timestamp for your application, for your data that's produced, for example. And indeed, if you're writing an application that allows people to play a game, as an example, maybe consider making those assets, emancipating the assets within your game, the achievements, the stats within your game, and maybe issuing, for example, a token that represents those on a publicly verifiable chain like Algorand, where your users will then be able to maybe use those assets across different platforms, rather than just having them bound to Steam or bound to PSN or bound to the Xbox Live. I think that when you start thinking in terms of the use cases, the real value of adding a blockchain component to some applications starts to emerge.
I love that. Yeah, it doesn't have to be the whole thing. It can start little by little and experiment and try it out. I think that is absolutely the right thing. And I think this is actually a nice way to maybe segue into our next segment, which is for all the happenings in our ecosystem, for a little inspiration of what are some potential projects you can work on. Let's please pull in our ecosystem correspondent, Fred.
Welcome, Fred.
Hi,
Hey
Fred.
man,
Hi,
John
Fred.
Mark. Hey, thrilled to be here. But hey, man, I gotta say that I'm a little bit embarrassed right now because
Uh-oh.
I got a memo to come here on the show and share some ecosystem news. And like it's news, right? So I put my suit, I put my Algorand tie on, but it looks like John and Mark didn't get the same memo. So a little bit
No, we
Well,
embarrassed.
didn't.
Hang on, Fred. I got you, brother.
All right,
We have
sweet.
to.
There we go.
Yes, we have to do better. We'll all be dressed up next time, Fred. We'll all be dressed up.
All right,
Sorry,
we'll
Fred.
see.
That's ridiculous. That's really cruel of us. I can't believe
there's
that.
nothing wrong with looking good. There's nothing wrong with looking good.
It's so good.
Awesome. Team, thanks for the invite. It's a pleasure to be here. So as Min just mentioned, I'm here to just give a very brief update on some of the latest happenings of our ecosystem in the last couple of weeks. So this will be, likely a short segment. I'm going to have to go fast. I will talk very fast. And, Stacy, over the last couple of years, she keeps reminding me all the time that I speak too fast. But today, that's a feature, not a bug. Okay? So that's going to serve me well today. But, for the Algo fam that doesn't know me, I'm Fred Estante. I work here at the foundation in Min and Christine's ecosystem team. I lead ecosystem infrastructure. And on my part-time, I also do a lot of Reddit and Twitter meets. So that's where you probably see me around. But, okay. So here to give the Algo fam today a quick overview of the latest ecosystem news and updates. It was really hard to just trim down because there's a lot of stuff happening, but I think I have a very good coverage. And in today's segment, I decided to actually divide the news by vertical. So I'm not going to do this in a chronological order, but again, everything's fairly recent, but I thought it was just easier to group everything together by theme, okay? So, I'm going to start with my favorite vertical, and I'm about to make some enemies here, but, you all know I'm a little bit biased for ecosystem infrastructure and platforms. I wonder why. So I'll start that, okay? So very first update, the amazing team at Transaction Lab just released the Ready pooling platform on testnet ahead of the Ready upgrade that will introduce consensus incentives to Algorand later this year. So this is already live on testnet. Anyone can join, stake, create their own validators, etc. It's a lot of, it's very interesting product, very easy to use interface. Highly recommend everyone to try it out and get comfortable with it. Moving on, Algonode, the premier ecosystem infrastructure provider in our ecosystem, just enforced rate limits on their free plans. So builders, mind your quotas, okay? And change your service plans, as you scale up so your service is not halted. Be very mindful of that. ChainTrail, everyone's favorite on-chain analytics, just added some real-world asset coverage by tracking climate trade on-chain activity. So even more RWA coverage for us there. Blockstalker, a buildable finalist, released the first major upgrade v1.0.0 just hit mainnet, and this update of the protocol brings some really neat features such as real-time streaming support, API keys, multiple data streams management, and many other things that you can follow on chain through a series of triggers and alerts that you can set up. And last in this section, but certainly not least, Daffy one of the wallet providers in our ecosystem, they just did two things. One of them is they did a conversion of their native token from Ardini to Daffy. So, any of you token holders out there, follow their structures. And also they just released a major Android app update. So make sure to update your apps. Okay, I hope that was quick enough, for everybody, especially for Stacy, but we'll see. On to the next vertical, real-world assets and DePIN, decentralized physical infrastructure. We have a newly launched project in Algorand called PyFi. So they just launched, I think last week or so. They are a DePIN project building software to collect, visualize, and share environmental and smart home data. They also launched recently an affiliate program, to reward referrals. And of course, we have everyone's favorite and infamous and famous Lofty, which just launched the first tokenized farmland in their platform. So it's 30 acres of farmland in upstate New York. Lofty also, over the last couple of weeks, just launched a few new AMM liquidity pools against already existing properties that were tokenized before, and they just reached $1 million in organic TVL against those properties through the AMM liquidity pools. And given that I'm talking about liquidity, yes, this is real land, real farmland, yeah, that can be productive. All right, but okay, so I was talking about liquidity pools, so it's just a good segue into the next vertical, which is DeFi. Lots of happening in the DeFi ecosystem in the last couple of weeks. So number one, DeFi app, one of the premier wallet providers in our ecosystem, just integrated non-fungible domains vaults. So now DeFi users can no longer need to opt into assets before doing anything on chain. Assets can just be sent to the user's vault as well. XBECT, a platform of DeFi vaults and decentralized stable assets, just distributed the rewards for everybody that it remained eligible during the Q1 vault holder reward program that they ran. Compex, which is currently building the next generation of DeFi tooling on Algorand, was the first DeFi protocol to actually try out Transaction Labs Ready pooling that I just mentioned before. So they're the first one to try out. They also have some stuff going on testnet. And Compex also just released some really interesting information about one of their upcoming functionalities that are just about to drop on lock drop. Just to basically give everybody a tool to to give everybody a tool to basically put in their liquidity and lock it for for a specific period of time, so you can incentivize more stable liquidity. So very cool, very cool upgrade that's coming up soon. Meld Gold, the tokenized gold on Algorand, just reached 500,000 transactions on chain. The C3 protocol just reached $4 million in TVL, having launched just recently as well. Focus Finance, they just announced a bunch of things, including the Q2 community coin contest, for all the degens out there, and they also just announced another round of consensus incentives for the current quarter. And to wrap up DeFi, given the very beginning of a new governance period, the TDR rewards for governance program governance period 11 just dropped and have started at Pact, Compex, TinyMan, and other DeFi platforms. So stay tuned. And then moving on to the last vertical that I'm going to cover today, which is NFT and gaming. Lots of stuff happening there as well. We have AlgoX NFT continue to drop several quality of life improvements. Recently, they just released a bunch of functionality that allows you to favorite, bookmark all of your favorite NFTs and collections, so you can keep better track of the stuff that they have your eyes on. Fractal Labs just teased some very exciting updates with dungeons, PvP lobbies, new monsters coming to the game. You're going to be able to build your own home and a lot more that's coming. And they also just released a social leaderboard, so you can compete with and see who's in the top 50 users and guilds that are playing the game. X NFT art has redeployed on mainnet, and their shuffles, their NFT shuffles are actually now powered by Algorand's on-chain randomness beacon. So that made me very happy, and I see John is getting very happy there as well. Another project leveraging Algorand's on-chain randomness beacon. And to wrap up today, at last but certainly not least, the project Realms, which has been making lots of waves in our community recently. So they just announced that they're about to release their website, with a bunch of information about the upcoming virtual world they're building, roadmap, etc. So they have been making waves because they have been partnering with lots of NFT collections and projects over the last few months, generating a lot of buzz in the community. Their graphs and visual identity are really fire, and I think everybody's pretty thrilled and excited, for what's to come. So stay tuned, because they're going to be releasing a lot more information in the upcoming weeks. Now I can catch a breath. I think I covered all that I wanted, but I truly apologize. There's a lot of stuff that I wanted to talk about today, but I didn't have the time. Otherwise, I'll be here for 5 hours or so. But hey, thanks for having me. It's been a lot of fun to do the segment today.
Fred, thank you so much for coming. I hope you come back.
Yes,
we'll
thanks, Fred. We'll see you back in 2 weeks.
Sounds good. All right, bye.
All right, thanks, Fred.
We should have more guests. We should have more guests on the show. I like having guests.
Yes, we definitely should. We definitely should. So what do you think? Shall we wrap it up?
Yeah.
Yeah, let's do it.
So hopefully this was a good episode for folks to just, get a better understanding of what it would take to actually develop for a blockchain. That's what we're kind of trying to achieve, right? So get those Python developers kind of inspired by the use cases that blockchains offer. And we didn't talk too much about Algorand itself, but of course the native Python implementation is only available in Algorand. And I would encourage all of the Python developers that are interested in this to kind of check it out. Go to algokit.io, sign up for some of our bootcamps. And I think we didn't talk much about it, but I think that the Algorand blockchain is particularly interesting for Python developers, because we've really been focused on kind of developing and enabling these solutions to develop at scale. And so a lot of these blockchains in the industry are still fairly immature. And what you don't want as a Python developer is for your success to be your demise. You build an app and you spend all of this energy in it, and you try to scale it, and suddenly it kind of falls apart because the network can't scale with you. And so So what's really interesting about Algorand is our focus really on these real world use cases and being able to kind of scale your applications. And so with Python, combined with the scaling ability of our network, I think as a Python developer, you can really go and try all of these use cases that we've tried to inspire you with, and see where it leads you. And so yeah, let's just wrap it up. Thank you, Min. Thank you, John, for another great Verifiably Random episode. And I can't wait to record the next one with you guys in 2 weeks from now.
Sounds great.
Yeah, it was fantastic. Thank you.
See you guys.
Bye, everyone.
Bye, everyone.
Bye.